had you started yet? I was
Yeah.
dancing. I was dancing for you. Okay, so we're doing November, December 2002. Yeah, that's the one.
So we kind of got the terms, we just don't know how to simplify.
Okay, so let's kind of work, you know what, the best way to learn how to do it is kind of work our way through it and kind of talk about it. So, visually, I think you see the same thing on your paper here. Looks just like it.
Mm-hmm.
That's pretty good.
Thank you. Okay, you have a diagram. OPQ is a section of a circle, center is 0, or O, sorry, radius R, and then it says that the angle QOP is theta radians. The tangent to the circle at Q meets OP extended at R. What is that? I mean, why does it sound like that? What does that mean when they say the tangent blah blah blah? What is the one thing you need to take from that?
The tangent line, if the tangent line meets the radius, then it forms a right angle.
Yes, very good. And so that's kind of where you're at. So if you look at that top right-hand corner there, or top whatever corner, you already know that it's a right triangle, right? Mm-hmm. Yeah, so you're good to go. Okay, so everybody's okay with that. Show that the area, A, of the shaded region is given by, and then they're giving me an answer. A is equal to 1/2 R squared tan theta minus theta. Okay, so area of the shaded region, does everybody agree, is going to be the area of triangle minus the area of the piece of pizza.
Uh-huh.
Everybody cool with that?
Yes.
Mm-hmm.
Are we sure?
Yes.
Yes.
Everybody's good. Excellent. So, how do we go about finding the area of a triangle? Tell me the formula.
1/2 base.
1/2 base times height, and then what's the area of the piece of pizza?
1/2 R squared theta.
Okay. There. So, what we need to do is figure out what's the base, what's the height, what's the R, what's the theta. Okay? Is everybody okay with what I just said? So, those are the things that we have to kind of pull together. So, knowing that this is the right angle, could everybody kind of tell me what they think is visually the base? Okay, which one's the base, and then which one is the height? Yes.
R is the base, the
Okay.
QO.
So R is the base.
And then QR is the height, which is also the tangent of theta.
Okay, so here is the base, here is the height. It's definitely not the one that's across from the right triangle, ever. So I need to kind of pull my head around it here for a minute and say, I need to fill in here, and I need to figure out what is the base. We discovered it to be R. So I remember it's going to be the area of the triangle minus the area of the piece of pizza. That looks like pizza to me. Are we good so far? So so it's going to be 1/2. What was base? You told me R. So far, so good. Okay, and then you also told me that this guy over here is the height.
Mm-hmm.
So how do we go about finding a side opposite of an angle, for instance? So I'm looking at my angle. Do you agree that this is the opposite of it, right?
Mm-hmm.
And what would this be in accordance to it?
The adjacent.
The adjacent. So opposite adjacent automatically says to me tangent. Yes.
And you know, like you wouldn't use like adjacent over hypotenuse because you don't know PR.
Correct.
So like how would you know to use it, you know, sine, cosine, or tangent?
I do know that we already have A, right? So I know I have to have one of the sine, cosine, tangents that has the adjacent in it. So I can eliminate, bless you, I can eliminate sine because that has no adjacent in it. Does that make sense? So the two that I have options for are the cosine and the tangent. And here's the dilemma. They gave me tangent as part of my answer, so that's what, and my brain is thinking that way. But I also know that I'm not 100% sure what's going on down here. So I understand that I have to actually use what I know. I know R, right? I know theta. Theta's our angle. Regardless of what it is, it's theta. So that's all I'm missing. Is that cool? So do you agree that, if I write it over here, tangent of theta is equal to question mark, what we're looking for, right? Which is this side here, over R. Is everybody okay with what I just said? So tangent of theta, no. Okay, yeah. So, do you agree this is opposite and adjacent?
Yeah.
So you agree it relates to tangents?
Oh.
So, are you owing or are
We
you?
don't know the opposite, but we know the adjacent.
Right.
So
We don't know over here, so I could call it opposite if it feels better with then question mark. So we're going tangent of theta is equal to opposite over adjacent, and we know adjacent is our radius. Is everybody okay with that? So now do me a favor, solve for the word opposite, because that's what we're looking for. So I'm going to take the r and bring it up here. Is everybody okay? So literally this is r tan theta. That's the actual measurement of that. Now, what if r had a value 2, for instance? What if theta actually had a value 30 degrees, for instance? We would actually have a value for the opposite side. But it's very obscure right now because it's in terms of r's and thetas. Okay, so back here, the formula for the triangle, you guys told me, is 1/2 base times height. Well, we had 1/2, we have base. Height, we just figured out to be the opposite side, so it's going to be r tan theta. And we'll clean it up in a second. Are we okay so far?
And then now we have to do next.
Okay, so minus the area of the piece of pizza. And remember the formula for that is 1/2 r squared. Well, what is radius in this case?
R.
So r squared. And then what's theta in this case? Well, it's theta. That was pretty good. So, kind of in my brain I'm saying, okay, do I have the word tangent, which I needed to have because it told me I needed to have? Yes. So look at what it looks like over here compared to what our stuff looks like over here. Yes.
No, you need to factor something out.
You can.
Factor out an r. And theta.
And
Factor out 1/2 r squared.
yeah, if I clean this up, it's 1/2 r squared tan theta minus 1/2 r squared theta.
So yeah, so you distribute it.
I cleaned, yeah, I multiplied it together. So the r and the r became r squared. So what do I have in common now? It's quite obvious now. 1/2 r squared, 1/2 r squared. Would you agree? So if I factor that out,
Oh my god.
what do you got?
1/2 r squared times.
1/2 r squared times tan theta minus theta. Happy face, I have what I want. Yes.
When you multiplied the 1/2 r squared to the tan theta, how come like it didn't distribute, like the r didn't distribute twice? How come it wouldn't be
Okay,
1/2 r?
That's a really good question.
Yeah.
Let's look at like a generic over here. So like let's say I have 2 times 3xy. I think that would help. It's very different looking than that, but the concept would be the same. I want you to multiply the 2 in here. What would you multiply the 2 by?
The 3.
Correct. So I would have 2 times 3 is 6. And then I have the xy that kind of goes for the right. What you're telling me to do is take the 2 and go 2 times this and 2 times this, which doesn't happen unless there's a plus or a minus in between the two things.
Because r tan theta is like one term.
Correct.
Okay.
Does that make sense?
Yeah.
So you see it with something we're very familiar with. So when it looks a little bit obscure, it makes sense now. All right, are we good? Okay. Now, the next thing is going to be, I think that's the first part.
Yeah, in the case where theta is 0.8 and r is 15, evaluate the length of the perimeter of the shaded region.
Thank you. So it says in that case, they're actually giving the actual values, and it wants the length of the shaded region. So I'm going to highlight that in a different color. So the length of the shaded region, I think you would agree, is this guy, and is also this guy, right? Okay, so what is the curved part?
The
length, arc length.
Right, the arc length, pizza crust, right? So right now I actually have the arc length. And right here, they told me what, 0.8?
0.8 and then r is 15.
And 15. So they give me some info. Right, are we good? Question, do I actually know what this side is now?
Yes.
I do, right? Because it's, what is it, 15
Tangent of 0.8.
0.8. And actually it has a value.
Yep.
What mode should my calculator be in?
Radian.
Good job. And so when you do the calculations, what do you get?
Well, 12 is for the arc length. I'm just saying. I didn't get that.
Oh, you already did that? Thanks.
It's the only thing I knew how to do.
That's what you got, right? Okay. So, if we were finding the arc length of this, you said it's r theta. Am I right? Yeah. So 15 times 0.8 would be just this pizza crust, right? And so what is this guy going to be? It's a really good question. What is tan 0.8 times 15? And I can write it out like this so you see what we're doing.
15.4.
Is it?
4.
Okay, so we have, you said this is 12, right? And then you said it's 15.44. And did it tell me to go to a correct decimal place or anything of that nature?
No.
It didn't, but well, when we have it like that and it doesn't tell us, let's go 3 decimals out. So 0.444? 5, thank you. All right, so far so good. So at this point I have this gone and I have this gone. Uh-oh, here's the big bad, right? What do I do? How do I get that?
A squared, B squared equals C squared.
Oh, tell me why.
Well, because it's a right triangle.
Good.
And then you do 15 squared plus 15.445 squared equals the whole thing, and then you minus 15 from it.
Does that make sense?
Yeah.
Kalia, what did you just say? Really good question. Yes?
Oh, can you write out like the work for that?
Absolutely. I was just trying to wake Kalia up.
Okay.
For the record, Kalia is snoring in class. I'm just kidding. She really is, though. Poor baby. All right, so we have 15 squared, this side, plus this side, which you guys just told me was 15.445 squared, equals the length of this whole guy squared. So it's equal to OR squared. Okay, so can somebody crunch the numbers for me?
225 for the 15.
Thank you.
And then what's 238.548?
Thank you.
And the whole thing, like those two added together, is 463.548.
Perfect.
And that square root is
21.53.
530.
So that is equal to OR in its full.
15 minus, well, 21.53 minus 15.
And everybody okay with why we're subtracting 15 from it? Because really we want red piece, not the whole piece, right? So minus 15, 6.53 is equal to PR. PR. Does that make sense? So back up to our little formula up here, we have to add all the red pieces. So to include adding PR, right? And I'll put that here so we can see for future reference is PR, which we found out to be 6.53. So when we add it all together,
33.975.
say that again.
33.975.
There is your answer. What do you think?
Do you have to put like centimeters? Like,
Did it start with centimeters? Yes. And it's perimeter, so therefore it's just centimeters. It's really not something they look for as far as the answer is concerned, but you know what? Let's be safe. So, we good? Okay. How do we feel?
Miss, okay?
Yeah, babe.
So like on
Go ahead. It looked to me like a big trike.
October, November 2010, 11. It has a 7 for the
yeah, we only did. We got to.
We had to do
II.
Uh-huh, that's right. That's it. That's right.
The area of the shaded region.
So we did get to a place. Erase all this.
and we did this on Friday.
We started on Friday, I believe. And I think we got to a place where I think confidently we could say that this was 6, this was 2, we discovered this to be 8, therefore that was 8. I think we did that all together, right? And then I think the last part said, oh, we did find RPQ together, 0.9, what was it?
0.927.
0.9272, I think is what we came. 3, so close. 0.9273. I think we came up with that, right? Okay, so that's something where we work together and then we end up at that spot. Now, how in the world do they want us to find the area of the shaded region? So let's kind of talk out loud. Yes?
You can find the area of the triangle and rectangle shape and then subtract 2 arcs.
The two pieces of pizza, right? Does that make sense? You don't want to call it by the proper names?
Pieces of pizza.
That's right. Yes.
Well, they called that a trapezium. I looked in the mark scheme. They said the region equals the trapezium minus the 2 sectors.
Oh, that's really funny. Well, it does because it's a four-sided figure that's trapezoid.
And they have a special formula for that.
Area of a trapezoid.
Yep.
The
Base 1 plus base 2, something blah 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 times height. Yeah. So what if I'm sitting in a Cambridge exam and I'm like, holy cow, I can't remember the area of a trapezoid. I can find the area of rectangle plus area of triangle and I'm fine. Okay? It does the same thing. So I'd love that you would recognize it as a trapezium slash trapezoid. But what if you don't remember it? What if you don't? So you might not. So let's try it like what we do know. And I think finding the area of a rectangle is fairly simple. We got that under control. And also finding the area of a right triangle is fairly simple. We've got that under control. So do you agree that 8 times 2 is the area of the rectangle? So what is that? 8 times 2 is 16. Plus, what is the area of the existing right triangle that's up there? It's 1/2 base times height. Would you agree? So 1/2 8 times 6. So 1/2 8 times 6. So if I'm looking at this right now, I have 16 plus 48, 24, correct? Yes. Check my math. 10 through 2, 3, 40. Everybody on the same page? Awesome. Now, how do I go about taking away the slices of pizza?
Arcs. So you find the big one, and you find the little one.
Okay, so I'm looking at the big one right now, and I believe I see that the radius of the big one is 8.
Yes.
And the small one's 2, so we're good there. So if I look at the big one, it's 1/2 r, which is 8 squared. And then what was theta? Well, we just found it. So what is it? 0.9273. Beautiful, right? So we need to kind of pump those numbers out.
Wait.
What?
Never mind.
Okay. I don't mind waiting.
No, I did that other one.
Okay. So what are we seeing here when we're looking at this? What are you seeing when you're, I'm seeing that right now I've got big trapezium minus this big slice of pizza. So all I have left to get rid of is this guy here. So right now I'm looking at this number. I've got 40 minus this minus a little piece of pizza. So how do we find the area of a slice of pizza regardless of its size, right? It's 1/2 r squared theta.
We don't know.
Don't think we go with that.
We don't know that. We know that theta, but we don't know that. angle.
Okay, but do we know r?
Yes.
Y'all told me it's what? 2. Okay, so 2 squared. Now our goal is to find theta. So let's talk. You actually do know it.
Oh, wait, yeah.
Yeah, you know this, guys, right? We found it. Tell me what this one is. 90.
90
But
degrees, which is something like here.
okay, so how do we go about taking 90 degrees and making it
Pi over 2.
pi over 2 in your calculator? What's pi?
3.14.
3.1415. Divide by 2, and what do you get?
1.57.
1.5708.
07. 08.
This angle, right angle, is 1.578. And so is this right angle.
Because they're like inverted.
Well, yeah, and they're both right angles, right?
Yeah.
So 1.5708, right?
Mm-hmm.
All right, but we're not quite there because we need that whole angle, right? So what do we do?
All the angles of the triangle have to equal 2 pi, right?
Have
Or
to
no,
equal...
1 pi.
6.08. Or
It's pi.
That's all the way around a circle, but we're talking about 180 degrees, right?
Yeah.
Which is equal
Which
to
is pi.
pi, which is 3.1415. So this plus this, subtract from 3.1415 will give me this. Does that make sense what I just said? All angles of a triangle add up to 180, but we're not in degrees, we're in radians.
Pi.
Pi, 3.1415.
Mm-hmm.
So
yeah.
could we just like keep it in degrees and then make it radians or no? Just do radians.
I have a feeling they're looking for the radians, so I would probably don't do that. Yeah. I mean, it's understandable that you would feel comfortable with radians.
Thing is 2.214.
Okay, so this whole thing is 2.214. What was the little guy here?
1.57.
The little guy?
Yeah, this guy.
0.6434.
I just put it up so we had it. 3.5? Okay, that's fine. So, do you agree that this is the angle of this guy here? So the formula is 1/2 2 squared times 2.214. And you have a little math magic to do with your calculator, and you should come up with your result. What do you think? Really, I think you guys have every single tool that you would possibly need to do these problems. It's just you have to figure out what to use when, if that makes sense.
175.
When's our testing?
Friday. Ooh, ooh-wee. I know, exciting, right? Yes.
Will there be like any unusual shapes? Like we need to know the areas
No,
for?
what you see is what you get.
So mostly just, rectangles, triangles.
Triangles, and areas of the circular sectors, also known as a pizza. Yes.
So I'm still confused on how you know when you're in radians and when you're in.
When I see decimals like that, I'm in radians. Yeah. When I see pi attached, I'm in radians. You're never really going to see degrees. Never. Maybe once.
Is it going to be 100?
Probably not. You know I won't pick up the test until Thursday, until I know what we've seen. Yeah. Okay, so, can y'all finish that one without me?
Done.
D-O-N-E done. Okay, the bottom of the front page was also asked for me to do, so I'm going to do that one real quick. I don't believe I think I'm here Thursday, so I think you have me for the rest of the week. I don't hear any cheers, so.
Woo.
No jeers, no cheers.
I missed you.
I missed y'all too. I drove the whole way, all by myself.
I would have made it easy.
Well, my dad was there, but and EJ was with Axe and One. I drove.
I would have been like, EJ, wake up. This is for you.
No.
Drive.
Are you kidding?
You would
EJ,
have died.
EJ, fall asleep.
You would have died.
Enjoy the ride. It was great. It was a beautiful drive, really. North Carolina is absolutely beautiful.
So which one is this that we're doing?
You asked for May, June 2003, I believe.
The bottom of the first page.
We're doing all
Oh, that one.
Bless you.
That's a, I don't know how to say that.
I got lots of things going. Hey, you have a semicircle. ABC. O is the center, radius 8. Okay. If that's the center, what do you know about OC?
It is
Radius.
Also, right?
Also.
8. And 8. So far, so good. What do you know about OB?
8.
Oh, it's 8. Very good. Why?
Because
It's also the same.
Yeah,
Yeah.
it's also that, right?
Mhm.
What do you know about, okay, so this is angle theta.
Mhm.
Okay, is this thing going to be in pies and stuff?
And then the other side,
Yeah, so what's this going to be?
180 minus.
It's 180 minus, but it's
Pi.
stuff is in term, right, it's pi, right? So this is pi minus theta. Do you agree?
yeah.
Okay, so we see that this is theta. So you know that a straight angle is 180 degrees, also known as pi. So if I know this, then I know this side is pi minus that. Did that make sense? Okay, so we haven't even looked at the problem yet, but we're trying to figure out what could help us through this process, right? Okay, so the next part. In the case where theta equals 1, calculate the area of the sector BOC. Okay? So in the case where theta is 1, and that is true just for this one eye in problem, okay? So we have to find the area of BOC. So I know the area of the piece of pizza is 1/2 r squared theta. Everybody okay with that?
Mm-hmm.
So what is R?
8.
8. And what is theta in this case?
2.14.
Because it's
Pi minus
3.14
Minus 1.
minus 1. But it wants everything in terms of, I think the answer should be in terms of pi when you're done. Maybe?
I mean,
It doesn't matter.
Doesn't specify.
It doesn't say, so let's just go with it. Okay, they're telling me it's 1, so calculate your little numbers, and what do you get? Something, right?
I got 68.53, but that's not in terms of pi.
They accepted it at 1.
Did they? You looked at it? Beautiful. Okay. Everybody cool with how that happened?
Mm-hmm.
Really not bad, right? Okay, the next one. Find the value of theta for which the perimeter of the sector AOB is 1/2 the perimeter of the sector BOC. Cool?
Mm-hmm.
So, the perimeter of this guy is half the perimeter of this guy.
Mm-hmm.
So, do you agree if I double this one, I get this one?
Mm-hmm.
Does that make sense? So, 2 times this is going to be equal to that. So, let's talk about how that works. So, 2 times the perimeter of this. Well, what is the perimeter of this side? 8 plus 8. So, 8 plus 8
Plus 8 theta.
The arch theta.
plus r theta, which is 8 theta,
Yeah.
right? Good. So does everybody see why I'm doubling it? Because it says this is half the size, so if I double it, I get that size. Does that make sense? So let's go to this side now. What is that equal to? 8 plus 8 plus,
8 times pi minus theta.
yeah, 8 times pi minus theta. Beautiful. So now we just have some math to do. We have a little bit of combining like terms and distributing and then solving for theta. I'll go over it again. It said that this is half the size of this. So I found the perimeter of this, and I found the perimeter of this, and I doubled this one,
Okay.
which gave me that. You sure?
Yeah.
Oh, okay. So far, okay? So, clean her up a little bit. I got 8 and 8 is 16 times 2, right? So 32 plus 16 theta.
Equals 16 plus 8 pi minus 8 theta.
Okay. So now I want to get theta alone, basically. My job is to solve for theta.
Mm-hmm.
I prefer to have positive theta, so I'm going to add the theta stuff over here and get rid of the stuff over there. So would you agree if I added this, I've got 24 theta, and then I'm going to subtract that. So
It's an 8 pi.
yep.
8 pi minus 16.
Yeah.
Divide by 24.
Okay, so I added 8 theta over here to get 24.
Oh.
Subtract 32 over there, don't like it in front.
I'm going to say 240.
Oh, sorry, it's a theta. Now I'm going to divide by 24. So 8 pi minus 16 over 24, which I think you guys would agree can all reduce by 8, right? Pi minus 2 over 3.
Isn't that something common?
Yes.
Would it be okay to use like a decimal answer?
No, because I think it wants it.
They didn't really
It
specify.
did specify. Okay. Yeah.
So you can do
0.305.
Yep.
Do you mind holding that? It might be apparent. Oh, are you really? No.
I don't actually work, you know.
All right,
Did
3
you bring
point.
your coffee that one?
He did. He's a good man. That's proven on record now. Okay, so moving on to the next one. In the case where theta is equal to pi over 3, show that the exact length of the perimeter of the triangle ABC is 24 plus 8 squared root of 3. So, do you guys see that the triangle ABC is this guy?
Oh, that was what I was confused about.
That's it.
How are they getting a triangle from that? Because it,
You created it.
yeah.
kind of triangle is it actually?
Right.
It's a right triangle. Where's the right angle located? At the B, right? Yeah. Very good.
Because those are
The one before it.
Say that again.
It's like the.
Yeah, it looks very similar to the one before it, right? So what do we know? Tell me what I know about this triangle now.
Well,
Yeah. What do we know about the hypotenuse?
it is 16.
16 in length, right?
Uh-huh.
Good, good. Do we know anything else?
right angle.
You know it's right angle. Excellent.
You know.
And what are they trying to get me to find? Theta is equal to 1/3 pi.
Where is that?
So if this is 1/3 pi, pi over 3, right? Then what's this guy over here? What is it?
Pi minus 1/3 pi.
So what's pi minus 1/3 pi? So what's 3 over 3 minus 1 over 3?
2/3 pi.
Thirds pi. Good, good. Excellent job. What else do we know? The perimeter. We're looking for the perimeter.
So we know that.
We can find other sides by using the angles and the sides.
We can.
SOHCAHTOA.
Right?
Okay.
Yeah. Oh.
That's a really good question now.
Because we have to make it look like 24 plus.
Yes, we do. We have to make it look like. We have to keep it in terms of ugly.
So
If that makes sense.
Is it something that's like, because the square root of 3 is like 30 something.
Oh, it's like a 1, 2 squared is a 3. Yeah,
Yeah.
yeah.
Is that what it is?
In agreement. Yes.
So, like, I guess what you could do. But see, the only problem when you divided it, when it's divided in those two triangles, they aren't right triangles, so you can't
That's
use
correct.
SOHCAHTOA.
Good job. Good job thinking of that.
So,
But the whole thing is a right triangle, so we could use SOHCAHTOA for the whole thing, right?
So the A to B would be, like, if we were to do the 1, 2 square root of 3.
Is it a mistake to assume
Let's say that again.
The 90 degree, that line that intersects the 90 degree is a bisector, so it cuts it in half.
Not necessarily because it's pi 3, 2 pi over 3, so it's not equidistant.
But could you put them on either side, like the 1 equals pi over 3? You know what I mean?
I think.
No, because it's on a, I know what you're saying, like, because it's on a curve and it's on another straight line up top, they're not, you know what I'm saying?
Yeah.
Because she's talking about when it's like a Z, you know, the angles inside, the interior angles are the same, the exterior angles are the same.
Oh, wait. Okay, so what are you saying? Say that again?
And like, when there's a Z,
Yeah.
the interior angles of the Z that are the same, and then the exterior angles are also the same. Like, those two are the same, and those are the same. But since this is a curve, it's not.
Parallel lines. Yeah.
You have what?
No parallel lines. You just,
Oh.
well, what if these were the principles of isosceles triangles? Because those are isosceles. So you know, some of the angles are the same. Like the angle for the small triangle, angle A and angle B on the small triangle are the same because the opposite sides are the same.
So you're telling me that because these are both 8, then these angles are both the same.
Yeah, which means
And you
can
already
take-
have pi over 3.
Yeah, so you can take, what is it, pi, subtract the pi thirds to get the addition of those two angles, and then cut it in half, and you have each of those angles.
What do you get? Pi minus pi over 3 is 2 pi over 3. Cut that in half, and what do you get? Start
Cut
over.
that in half.
So,
Pi.
so these are the same. Yes? Everybody cool?
yeah.
So this and this are also going to be the same,
Yep.
Pi over 3.
right?
Yeah.
So these are the same angle. They have to add up to what?
Pi.
1 whole pi. So pi minus this guy. So what's 1 pi minus pi over 3?
2.
Pi's over 3.
Yep.
So each of these angles have to be equal. So we're going to take
That's an equilateral triangle.
so 2 pi divided by 3 times a half is, agreed, pi over 3. So that means this
It's 8,
and this,
And then that line's
and that
also
one's
8.
8.
and that's 8.
Same thing with the other. Now, the other side, you would.
You have to.
Do the same thing, it's going to be pi over 6.
Yes.
How do you know that's 8?
Okay, can somebody explain that to him?
Because whenever, so an angle and then the side opposite from it always go together. And if they're all the same angle, that means the side opposite from each angle is the same.
So is this is really now an equilateral triangle?
100%.
But I thought in an equilateral all the angles are the same. Oh wait, no, they are. Yeah.
Ah, discovery. The light bulb is there. We love it. Okay, so now we have 8 and 8. Good. So what do we know about opposite sides? They're also, the opposite angles are also going to be shared, correct? Is everybody cool with that, what I just said? So if these guys have to have same angle. So if we know the whole thing is pi minus 2 pi over 3, what are we left with? 1 pi over 3, yes? So then what are each of these angles supposed to be? Pi over 6. And does it make sense that, oh, that's a 6. That was really close. And that's a 6? Tell me something. Does it make sense that pi over 3 plus pi over 6 is a right angle? Yes.
Yes.
Yes or no?
Yes.
Yes, it is, actually. Yes.
Well, see, 90 degrees is pi over 2.
Say it again.
90-degree angle is pi over 2 in radians.
Yes.
So both of those angles should become pi over 2 when you add them
You
together.
want to see it? So we have pi over 3 plus pi over 6, right? And we get a common denominator of 2 pi over 6 plus pi over 6, which is 3 pi over 6, pi over 2. Ooh, we know that anyway.
Okay, and
Side.
now we have to do BC, and it has to do something with square root of 3.
I
We
think
do
we
A
can
squared
just,
plus B squared is C
That's
squared.
right,
is
because
16 and 18.
now we have a right triangle. We have 16, we have 8.
You said find C right.
You just have to find a squared plus b squared is c squared. I think life would be a lot easier. Right?
Yep.
So, do you agree that this is my right triangle? So that's my hypotenuse. So it's 8 squared plus BC squared equals 16 squared. Is everybody cool with that?
And then
Oh, this brought back a lot of memories.
the square root of 192 is
Oh, is that what it is?
8 to the square root of 3.
So BC squared is
Do you want the decimal? Or do you
it
want
192? Is that what you just said?
Yeah, and then you take the square root of that.
So what's 16 squared?
256.
Minus 64, 192. And what's the square root?
The 8 to the square root of 3.
8 squared of 3.
But they're asking for
But the
24.
answer has to be, right, ugly, right? So 8 squared of 3. Okay, excellent.
And then that's-
Now we add them.
and then 8 plus 16 is 21.
Now, what the heck do they want us to do?
That's 8 plus 16 plus 8
Find the
to square root
perimeter.
of
Okay,
3.
so this plus that is your final result.
It's 24.
Okay. That was a good, really, really back in the geometry.
But that was literally only 9 points.
That was fun.
Yes. Question.
Will there be a question like this on the test?
I haven't made it yet, but yeah, probably. I like that kind of question.
One that's like real involved?
Suppose, yeah.
This entire chapter is just circle puzzles.
That's all it is. You got to know your little angles. You got to know your geometry.
Uh-huh.
You got to be a
Can
bit
we
of a
use
reminder.
the circle on the test or no?
I don't see why not. You've already been studied on it. I just need you to know it by the end of the year. Again,
You know what?
the unit circle. If you feel like you need that as a, yeah. Okay, so I'd like you to try some without me. I mean, I'm here.